about the furnace operations, mainly in the downstream. So we have furnace operation as a value addition, and so I thought of addressing one or two value-added operations to enhance the furnace efficiencies. So my topic is contactless stirring of bath. Contactless, which is very important. No interference in the furnace, direct furnace interference, and a technology which can recover up to 95% aluminium from the dross. So these are the technologies which are not rocket science, but these are the technologies evolved over a period of time, and the technologies that are available with ALTEK are very promising, and they can guarantee you 95% recovery of aluminium from the dross and 100% recovery of aluminium from the dross in their patented technology called RAM technology. Okay, so Priyanka, next slide, please. So I just thought of putting that flow of my presentation. So one is, let us start with the ALTEK video on complete dross management value chain. Then I will briefly take you through the ALTEK journey. Then I will come to the cast house. What are the expectations out of cast house for any operation head or the cast house head? What are their expectations? So key performance indicators. Then bath stirring. So what are the bath stirring technologies available, and what can be done with the contactless? And then what is the advantage of contactless stirring over conventional, as well as within contactless stirring there are technologies available with ALTEK and some other companies. And then a complementary technology which ALTEK is developing, which is an online spectroanalyzer. So very interesting patented technology, and it will be launched in 2026. After we complete the stirring and everything, the aluminium is ready to come out. But before that, there is a process called drossing. So we remove the dross. So when we remove the dross, how do we treat that dross? Because generally the attitude for the cast house is to neglect the dross as a byproduct. So instead of that, how can you get value out of this dross? So I will speak about dross generation and its handling post skimming operation. Then primary recovery of aluminium from the dross press as a way forward. Then what are the factors in designing the dross press? Very, very important. ALTEK dross press advantage. And then after we dross press, which is called as the primary dross, then we come to the secondary aluminium dross recovery, which is a very huge process. I will just speak very less about it. But point number 6 over there is a RAM technology, RAM, which recovers all the aluminium, and the balance output, balance residue go as a bath cover in the pot room. Lastly, I thought of putting some strategic thinking about the dross management. So these are my conclusions at the end, and then I will be able to look at the questions. May not be able to answer anyone or all, or maybe able to answer one or two, but I would rather be hopeful that these questions are thought provoking. Okay, so Priyanka, why don't you take me to ALTEK video dross? Yeah, she will run this video.
Since the very early days of aluminium production, very little has changed. Today, ALTEK is rethinking, modernizing, and transforming the entire cast house, using the latest technology to make it more efficient, more productive, and kinder on our environment. Just think of what that could mean for you. We start with a furnace, where the dross is skimmed into dross pans. This is then transferred immediately to the ALTEK dross press, where large amounts of aluminium are recovered, often as much as 25% being squeezed out of the dross, and recycled back into the furnace. The remaining compacted dross, once cooled, can be easily stored, ready to be put into ALTEK's tilting rotary furnace, where salt flux, a crucial ingredient in the separation and recovery process, is also added for operational safety and to maximize further aluminium recovery. Once the burners have been ignited and the charge fully melted, ALTEK's unique multi-directional door is partially reopened to minimize heat losses. And with a holdback rake placed across the small opening, the rotary furnace is tilted forward. The molten metal is then decanted through the gaps in the rake, either directly into sow molds, transferred into a holding furnace, or recycled in its molten form via crucibles, straight back into the main furnace. The salt slag, the residue that remains, is tipped into salt slag bins, where it is cooled rapidly to preserve any remaining aluminium units. The cooled salt slag is then transferred to the alusalt process, where it's mechanically crushed and the last remaining aluminium is recovered. The remaining slag is mixed with water until the salts present are dissolved. The resulting slurry is poured onto a moving vacuum filter bed to extract the salt water, leaving behind undissolved non-metallic product. The non-metallic product is then quickly dried before being transported and used within a range of Harsco's high-performance eco-products used within the steel, ceramics, and cement industries. Meanwhile, the extracted salt water is fed into a crystallizer, where the water content is evaporated off, leaving only crystallized salt. The recovered salt is collected and can be immediately reused in the tilt rotary furnace as a salt flux, again and again. ALTEK's multi-stage total dross management process recovers up to 95% of available aluminium from the dross, the highest aluminium recovery when compared to other competing technologies. Our end-to-end technology solutions with zero waste and no landfill are making the cast house more efficient, more productive, and kinder on the environment. Some people think it's alchemy. We see it as simply advanced thinking. Since the very early days of aluminium,
Priyanka, you take the slideshow. You can share the screen, no problem. So the next screen, next slide, please. So about the ALTEK, ALTEK is a technology-based company dedicated to aluminum industry, and they have huge setup in UK and USA. I have visited UK setup recently, and they in fact have a very dedicated team for design engineers in the field of electronics, electrical, mechanical designs, process designs, and artificial intelligence and machine learning. So they are coming up with the new concepts. They have manufacturing facility, one in the UK and one in the US, and installation of aluminum dross and scrap processing plants. References all over the world. Very old company, and some of the major clients are Novelis, Hydro, and for many years. And in India, some of the clients are Hindalco and Balco and Vedanta as well. So the category of the product is first line product, which is electromagnetic stirrers, which are contactless, and the DROSS press. And the DROSS press requires DROSS pans. And after compaction of the DROSS, there is a terminology called skull. So that skull goes to the rotary furnace, and then they have come up with a on-spec online metal analyzer, and the tilt rotary furnace is a part of the alusalt process, where the skull is treated with the salt to recover the balanced aluminium. REM technology doesn't use any salt. So this is also one of the proprietary technology, which is right now implemented in only one plant in Canada, I think in Canada for last 4 years, and they are recovering 100% aluminium total. Up to 25% in DROSS press, balance 75% in the REM technology. And it has been taken over by a company called Harsco. So they have a big setup in Hyderabad as an Indian entity, but a big setup in the US. And that Harshco is also part of a company called NYRE. So this is a US stock exchange company, around $5 billion turnover company. And Harshco has bought this because the processing of the dross has an end product called non-metallic product, which goes into the steel industry, which Harshco buys. So Harshco typically set up the plant within steel plant to treat the salt slag, treat this slag on the steel formation. Next slide, Priyanka. So when you look at the cast house operations, there are typically many factors which are expected, but everybody expects that the melt cycles must be as small as possible. Melt loss should be very low. Of course, heat loss is a very critical factor that is monitored. Alloying should be perfect in time, quick alloying time. Homogeneous bath temperature for alloying. Least or zero dross generation, but less dross generation is one of the performance indicator. Maximum aluminum recovery from the dross, and dross handling and disposal. So these are some of the, and safety of course goes without saying. So these are some of the parameters which I have listed. There are many more, but these are from the today's topic. I thought 9 factors are important. Let's go to the next slide. So this is a contactless EMS stirring. So what is contactless? In this case, the furnace is having a closed door, and the EMS is a set of magnets which are created by inducing current in a copper coil inside this core, which you can see on the top. ALTEK has a typical brand name called CyberForce, and these magnets are so powerful that they can stir the bath to the extent of 120 tons. So these are very effective way of controlling the bath stirring operation when the door is closed. There are conventional methods of stirring the bath with a forklift, or stirring the bath with the manual intervention, or with the metal circulation pump. But these are all mechanical and they come in contact with the liquid aluminum. But in case of EMS stirring, it is contactless. And this is one of the promising technology for furnace operations. How does it help? So if you look at the melt cycle, it reduces the melt cycle. It reduces the melt loss. It increases your homogeneity. So I have jotted down all those advantages. Let's go to the next slide. So concept is based on the principle of linear induction motor. So a low frequency air cooled inductor is placed on the bottom or the side of the furnace. So EMS are put at the bottom of the furnace with a gap of around 100 mm, or they can put on the side of the furnace. If suppose there is a twin chamber furnace with a circulation pump, then they are put on the side of the furnace to implement the proper circulation. One of the beauty of the circulation is it can circulate in one direction. After 2 minutes, it can circulate in another direction. It's like churning of the buttermilk to get the proper homogeneity and bath temperature. The concept is when the magnetic field is created in the EMS, through the bottom of the furnace, it penetrates through the refractory into the liquid aluminum. So when the magnetic field is introduced into the liquid aluminum, it creates a induction current in the liquid aluminum. That current creates a magnetic field which opposes the entering magnetic field in the opposite direction. And as you see, when the North Pole comes with North Pole, it rejects each other. So that creates an internal turbulence, not turbulence, a circulating current. And this is how the circulation takes place. Now, this is not like circulating entire bath. So what it does is that magnetic current is, the magnetic waves are created at one place. It's like in the water tub. If you create the magnetic, if you create the waves on one place, it will after some time, it will slowly rotate the entire water. The same principle is here. The magnetic fields are created at one place, but in a waves, continuous waves, and these waves push this liquid aluminum in one direction. After that, the magnetic waves are pushed in other direction, so the bath turns in other direction. Most important, no physical contact is made with the molten bath. So your furnace remains intact, no heat loss, no door opening, no manual intervention. The system comprises of no moving parts. So there are no moving parts, so no maintenance. Only thing is you have to clean this EMS once in 15 days out of dust and everything. That's all. The current creates a lot of heat inside this induction box that has to be dissipated. So there are conventional ways of designing the conductors, which are like hollow copper tubes around iron core, which are supplied by other companies. And ALTEK, what it does, it uses solid copper bar. So what happens is there is no water circulation, there is no water near the furnace, no accident. And because of the solid copper bar, there is a large surface area from where ALTEK puts a flow of the air from one side, take the air from the other side. It's called as the induced draft. Because of the induced draft, it dissipates the heats. And so the heat loss is also very, the heat dissipation is very less, very fast. That is why the power of magnetic field is very high. That means the current drawn by the EMS from the main electrical panel is very less. Power consumption is very low. Next slide. You can see in this diagram, which I explained to you, is there is a traveling velocity of the magnetic field at the bottom, and then there is a electromagnetic force created by the induced current. And both of them repel each other, and that is why these waves are created. On the right hand side, there is a simulation, and at the bottom you can see those copper bars which are circulated across a iron core, and that is how they design. So these are all technologically advanced designs, and these EMS are capable of stirring the bath up to a level of 120 metric tons. That's the capacity that we have proven. Next slide, Priyanka. So expected advantage of EMS are increased productivity. So there is a increased thermal transfer of the burner to the solid matter. So when the furnace is half filled with the liquid metal and half with the scrap, you can have the EMS so that there is a improved flow of the heat from the burner, improved alloy dissolution, and reduce the dross formation because the door is not open, so there is no direct oxidation, and so dross formation is also very less. And all contributes up to the increased productivity by 25%. Now, this is a major parameter for the furnace operations. Energy savings. Typically, these are used using 90 to 140 kilowatt hour per furnace cycle. So it also reduces your fuel or gas consumption by as much as 15%. So productivity increase, consumption reduction in energy cost by 15%. So there is a huge benefit, and the accumulated benefit gives you the payback period of less than 1 year. Now, temperature and chemical homogeneity. So once the stirring cycle is initiated, the thermal gradient between the top and the bottom of the aluminium, within 5 minutes, you can reach 5-degree temperature. Otherwise, this temperature at the top, because of the burners, is always superheated. And at the bottom, it is there is a temperature gradient which is more than 20 to 30 degree. But because of this stirring, this temperature gradient is up to 5 degree. That gives you a very better homogeneity. Now, the stirring is not only in one direction across this, but stirring is also like this. So like this and like this. So it is like multi-axial stirring without turbulence and no contact of outside air because the door is closed. Now, we have done one study when I was in RIA that if the furnace door is open for 10 minutes, any any furnace operations will minimum lose $1,000 for 8 minutes. So if you remember, if your furnace is open and if you are stirring the bath with the blades by forklift or any other type of machines, you're losing actually $1,000 per 8 minutes. And typically one cycle takes 15 to 20 minutes. So $3,000 is lost. But with this door close, you are saving those $3,000, which is intangibly added to your profits. Priyanka, next slide. So what are the versatility of the EMS made by ALTEK? So ALTEK's EMS are bottom mounted, so it can go below the furnace without touching the surface of the furnace. There is a modification which is required, which is like putting up a steel plate at the bottom so that the magnetic force can go from the bottom into the furnace, piercing through the refractory. So the bottom of the furnace and the refractory. So it pierces through this up to the top level. Height of the bottom is say like 800 mm or something. It has a curved, ALTEK can make a curved EMS. So if you have a round furnace, it can make a curved EMS which can retrofit to your existing furnaces. And it can be mounted to your side well, where you are putting the scraps in form of chips or swarf. You can put the EMS on the side wall so that your melt rate is also faster without any oxidation. So ALTEK EMS is extremely powerful and can be used in many stirring applications, bottom mounted, side mounted, and for sidewall chamber pumping and multi-chamber circulation and more. So we are currently working on one or two clients where there are big multi-chamber furnaces, and we are working on EMS which can help their current mechanical pump. Mechanical pump causes problem of mechanical maintenance, failure of the shafts, and choking of the pump. But in case of EMS, all these factors are negligible or zero. Next slide, Priyanka. Yeah, so these are some of the pictures of how the bottom mounted EMS is put. Now, one EMS, for example, in this particular case, the photograph on the left side, the EMS is weighing around 5 to 6 tons. So when you want to mount this, it is put on the rail and it slides below the surface of the furnace, and then the furnace can be horizontal or it can tilt when it is ready to discharge. And it has a scissor lift operation also. So you can have a EMS at the bottom of the furnace and it can move when it is ready for the stirring operation. The scissor lift will take it to the bottom of the surface and it can start the EMS operation. Next slide, Priyanka. So there are many advantages, but mainly I thought of 3. I will just read because it's too many words. So the stirring action created by the Cyber Force, which is a brand name, EMS is more effective compared to other technology, allowing all parts of the furnace to be stirred rapidly and homogeneously. So rapid stirring and homogeneity. Within 5 minutes, you have a homogeneity. The inductor is 100% air cooled, reducing the power consumption when compared to other devices. In other devices, for example, there are companies like ABB where the copper tubes are hollow and then they are circulating water for cooling. Now, it requires a water treatment plant, a chiller plant, and then the problem of choking of the tubes. But here it is 100% solid tubes, so air is flowing over the surface and it is reducing the taking away the heat generated during the EMS operations, eliminating the use of water around the furnace. So this is more important from safety point of view. The Cyber Force EMS can be fitted to both the side and at the bottom of the furnace, making it uniquely suitable for both new and retrofit installations. Okay, next slide. My goodness, so many points. So there are advantages over water-cooled old technology. So there is a lower annual operating cost by around 25 to 50% due to lower power consumptions. Inductor coils are made from solid copper conductors and not tubing. There are new tubes. There are improved heat losses within the stirrer as compared with a water-cooled hollow copper tubing, allowing the inductor to be air-cooled. Installation and maintenance are easier because there are no other materials rather than copper tubes. As they provide for long life, means the EMS work for many years with a minimal maintenance. No emergency water backup supply is needed because there is no water used. As there is no water and no hollow copper tubing within the inductor, service requirements are much lower and the risk of contamination or deterioration to the copper tubes and the inductors over the time is zero. No physical contact with the melt. And as the EMS inductor has no contact with the furnace wall and no internal moving mechanism, there is negligible wear, providing improved product life cycle, reliability compared with other water-cooled cold stirring technologies. Yeah. Next slide, Priyanka. Some of the pictures of this EMS. The picture on the bottom side of the left is a rail-mounted EMS which can move from one furnace to another furnace. For example, if you have cast house with number of furnaces in line, it can be made with 2 furnaces having a bottom channel and the rail mounted so that it can move automatically when the furnace is ready for EMS stirring. So there is a control panel. So the next slide will show you about the EMS. Next slide. Yeah. So there is a control panel which has three to four major parts. One is a control panel for moving parts. One is a power bank, and one is the HV panel where there is a power bank which is converting AC current to DC current, and from there it is converted into again low frequency AC current which sends currents in sort of waves one after another. So the EMS core will have say like 1 core or 2 core or 3 core depending on the design. Between 2 cores, it will go. The current will go one after another within fraction of seconds, and after 2 minutes, it will change the path. So this will go first, this will go second. So the current will move in the reverse direction. So the bath will also move in the reverse direction. Very top to bottom, and directions are different. This is very important to have the homogeneity and uniform bath temperature. So these are the control panels. It has a remote HMI panel, so you can have the data on your mobile as to how the EMS is working and how it is improving the melt rate, how it is saving the energy, how it is making the furnace ready ahead of time by 25% than the conventional one. So these are a lot of advantages of this type of EMS. And there are big companies like Novelis are very fond of ALTEK EMS. Yes, next slide, Priyanka. So this is a typical simulation. The EMS can start to work once liquid aluminum in the bath is present. It has to have some liquid aluminum. This melting part of the cycle can be reduced due to the improved heat transfer from the combustion space to the melt and the hotter aluminum breaking down the cold boundaries layer covering the submerged scrap pile. So if you have a furnace with a bottom liquid metal and then there is a charge which you can put inside and the furnace door is closed. So rather than burner going to only wait for the scrap to melt, the EMS can start stirring the bottom liquid metal and it will start improving the heat transfer from the burners or the refractories into the solid scrap so that the melt rate increases. And because the furnace door is closed, the melt loss also reduces. The next slide. So there is a graph. So if you see on the x-axis, within 270 seconds, that is after 4.5 minutes, the temperature of the top and temperature of the bottom, they matches. So once you start the EMS stirring, the temperature becomes uniform throughout the furnace. And this is a test on the 80-ton furnace, which we have plotted. So that is our ALTEK EMS performance. Yeah. Next slide. So how to complement ALTEK? EMS is the one which we are now going to launch in the next year once we get the patent out of this. So this is called, am I audible?
Yes. Very.
Priyanka, I think the
We can
slide
hear
has
you,
gone
sir.
off.
No problem. We can hear you clearly.
Yeah, okay. And I hope I'm not feeling you bore. Huh?
No, sir. Please continue. No, nothing.
It is very exciting,
Interesting.
very excellent presentation going on.
Oh, thank you. Thank you very much. I will try to improve myself. On-spec is a patented technology which is called as a laser-induced breakdown spectroscopy. So the technology, as far as I know, very Mickey Mouse, is the probe goes inside the liquid aluminium, and then there is an argon bubble which get fired into this probe, into the liquid aluminium, and within the argon bubble is aluminium, which is aluminium and the components like silicon, magnesium, chromium, all those components get absorbed in that bubble. And because the bubble temperature is very low as compared to the liquid aluminium, the electrons which are excited in the molten aluminium try to cool down. So when the excited electrons comes to the next level of cooling, they radiate some spectro rays, and these are captured by the laser, and then they are analyzed. So within 2 minutes, you can analyze 450 readings by putting the bubble and analyzing. So within 2 minutes, you can have the 100% accuracy of the composition of the laser, composition of the bath. So how does it help? So when you are starting a alloying, you put a lot of alloys, and then you close the door and start mixing through the EMS. To reduce the circulation, you need to know whether your composition has reached to that level uniformly. To know that, you need this probe. Otherwise, conventionally, you again take the sample, take it to the lab, get the results. In between, the door is open and you're losing $1,000 for 8 minutes. Now, this is huge because each furnace has at least 3 to 4 cycles, and in each cycle, you lose twice, opening the door twice or thrice. You're losing $3,000 per cycle. So many cycles in a year per furnace, you're losing money actually. That's why where the profit has gone. That's a big question for this aluminum cast house, because they are not producing value-added product as compared to the foundries, aluminum foundries. So on-spec is a one which is in very high demand right now, which we will introduce in new year. Is a laser-based breakdown spectroscopy technology which allows the use real-time process control, enabling a number of benefits, including the potential for tighter chemical tolerances. So in the alloy, you can have a tighter chemical tolerance which can be monitored, the ability to determine when alloying additions have dissolved, and the ability to essentially alloy in real time without the need to take samples and wait for information back from the lab. So it's a big time saving. With some cast houses waiting up to 20 minutes to obtain their material chemical analysis results before proceeding either with the furnace adjustments, casting, or transfer, on-specs allows production to take control of their efficiency and give immediate results, overcoming any delays. Utilizing on-specs laser technology by taking 400 lip samples in 2.5 minutes, the data obtained is absolutely accurate and recorded in the ALTEK software developed industrial data center. So you can have that batch-wise data of your alloying performance for each batch, and then you can improve upon that. Whether you should, in the alloying elements, whether you should have the sequence of alloying one after another, or change the sequence of with the different sequence of alloying with second and then first and then third and fourth, something like that. Okay, next slide. So this is where the probe directly goes inside the liquid aluminium. So this is a graphical represent. This is a picture of our trials. But in real sense, it is going to be a probe piercing through the liquid aluminum inside the furnace. So metal quality is critical and essential parts of the finished products, and the control of this as an integral part of the production process on spec is a laser-induced breakdown spectroscopy allowing real-time process control. Big saving in your alloying cycle from 20 minutes to say like 2.5 minutes. So 18 minutes you are saving in alloying. It's a big saving. Already cast houses are asking for them to get acquainted and waiting for this to get introduced. But we are waiting for a patent. Once the patent is allowed, we will be able to launch this. Ultimately, the aim is to save your money, cast house money. Yeah. Next slide. So this is the graphical representation. So the probe will go into the molten metal. ALTEK control panel will give you the remote HMI. So on the mobile phone, you can see the analysis online of the melter. So the operation head looking at 4 cast houses, each cast house with 6 to 8 furnaces. So 24 furnaces, he will be able to look at on the, anyway, we are putting an artificial intelligence model also as to how the analysis will look into. Yeah, next. So on specs is a complement to your EMS. So some of the points that I have jotted down again and again, I am telling it. No sample preparation as it is in situ analysis. It is help in reduction of overall cycle time of the furnace. Continuous online feedback on melt chemistry. Faster response time to melt problems. Because when you are alloying and if the alloying is not proper, then again you have to go for the alloying. So that is not required here. Increased operator safety because you are not opening the door, taking the samples, and real-time process control with 400 LIB samples in 2.5 minutes. It is online spectro accuracy with data recording, and it is safer operational practices. For EMS, it is a complementary because it reduces bath stirring time due to homogeneous bath alloying. So you come to know that alloying has taken place, so you stop the circulation and ready for discharge. Yeah, the next slide. Now comes the DROSS press. Very interesting. So these are latest generation DROSS press. You can see on the left is a DROSS press with an automatic door, and it has sensors inside. So when you put the DROSS pan inside, it automatically takes into account the position of the DROSS pan, and the DROSS press head will come down and it will press the DROSS. The next slide, Priyanka. So the DROSS press works on the principle of compressing and cooling the DROSS as quickly as possible with its press head cooling technology. So the head which is pressing has a cooling technology. So it cools itself and it becomes like a heat sink. So it absorbs the heat from the DROSS. So your thermiting of the DROSS reduces, and evaporation of aluminium into the converting into aluminum oxide or due to thermiting into the vapors is greatly reduced. This preserves valuable aluminum which would otherwise be lost to the oxidation. So the loss is 1% of the DROSS you are losing as an oxide. Once you create an oxide, you have further processing required, and it is per minute. This benefit comes in 2 forms. In-house, you are in-house draining, and after the compression, there is a post-compression skull. It has a large amount of aluminium trapped inside that skull, which you can easily recover. I have seen the best cast houses where they take the DROSS and spread it on the floor for allowing it to cool, but that is not the right practice because you are already oxidizing that, and because of the DROSS which is coming at 1000 degree, sizable amount of aluminium also get evaporated. And if you are de-drossing activity is manual, then your forklift operator will skim more of the aluminium rather than the DROSS. So these are the factors for which you can prevent loss by way of recovering the aluminium. So what we do is we provide the DROSS pans which are of special alloy, and it is a two-piece cast steel pan set. So the pan set is top and bottom. So when the DROSS is taken into the top pan, The entire assembly goes into the press, and when it is pressed, the liquid aluminum drains into the bottom pan. You get a real ingots, ready-made ingots, which is a alloy which you can directly put into the furnace. The full DROSS pan is sent directly to the DROSS press, where the automatic cycle will begin. Why it is automatic? Because once the DROSS pan is put inside the furnace, inside the DROSS pan, just press one button and everything will be automatic. Pressing cycle means door opening and closing cycle is 6 minutes. Within 6 minutes, you can press the DROSS. Now the DROSS pan capacity are 50 kg to 3 tons. So we have 3 tons DROSS pans. You skim the DROSS, put it into the pan. Pan should be 80% filled. Take that pan into the furnace, into the press it. And we can tell you that the recovered aluminum is 25% of the weight of the DROSS. Okay, next slide. After the cycle has finished, the pan is left to cool. So you take the pan out, keep it for cooling for 1 hour, and then you just tilt the pan with the forklift. The shape of the pan is such that the entire skull come out as a one piece, rather than disintegrated powders or something like that. Within the press, there is a fume extractor, so it extracts the fumes. The processed DROSS skull can be stacked easily and neatly one on another, and it can become a very easy material handling. And the metal drain ingot formed in the saw molds are returned to the melting furnace for remelting. So this is a graphical representation. Next slide. So worldwide, there are over 550 references and most widely used technology of ALTEK. It is robust and proven best technology for recovering aluminum from the DROSS. It is built to the stringent standards. It is UK and German standards to maximize aluminum recovery. The pans do not deform. The DROSS press works for at least minimum 10 years without and the pans without any deformation. It is lowest operating cost and rapid payback of less than 1 year. Within 1 year, you recover your money. The current practice of for furnaces is to skim the DROSS, treat it as a byproduct and send it outside, maybe for another reason. But if the top management is really serious, they should implement the compaction of the DROSS and recover the aluminum within the cast house so that their money is inside and intact. It is ultra reliable. It is a safe and cleaner working environment. Automated reporting statistics. So we have the data which can report it batch wise, furnace skimming cycle wise, pan wise, it can record the data. Now we are coming up with the, we have also a technology where we can actually see the weight of the DROSS when it goes inside the press and then when it comes out of the press. So it gives you 25% in-house drains. So 75% aluminum is trapped in the skull, and it is not aluminum oxide due to thermiting. When there is a pressing, the press head and the pan both becomes heat sink. So it immediately absorbs the heat out and the DROSS cools and the aluminum gets solidified inside the skull, which is 75%, which you have to recover, for which ALTEK has AluSalt or REM technology. Does not occupy large space. So it is a very nice, clean, machine with a supporting fume extraction and hydraulic power bank. And the fume extraction can be also integrated to the existing fume extraction mechanism or the through the headers or manifold. And it's absolutely clean atmosphere. Next slide, Priyanka. So these are number of steps. So you can see the DROSS is very high temperature thermiting. So when it is hot, between 1000 degree, the temperature starts cooling down to 780 degree, which is a temperature where the DROSS should be pressed. If it is cooler than that, it has no value. It will not squeeze the aluminum. But between 1000 to 700 and 750 or so, there is a time available. DROSS doesn't cool suddenly. So there is a time of 25 minutes. So within 25 minutes, the DROSS should go to the to the DROSS press should be put inside and press. Pressing cycle is 6 minutes. The third slide is bottom. See, after compaction, the skull is looking like this. You can see the entire skull covered with the aluminum which has come out of the skull and squeezed. There is an artificial intelligence that we are building, but entire data is captured. Next slide. These are the two DROSS press where you can have enhanced capacity, and the DROSS pans are two. In one DROSS pan, there are two compartments. So you can skim more DROSS in two compartments and you can have press simultaneously. On the right side, you can see the hydraulic power bank, and on the top is a fume extraction which is extracted. You can imagine the head comes with a hydraulic power of 90 tons. So you are pressing the DROSS at 90 tons in that confined space. So the all liquid aluminum goes and drips into the bottom saw mold in less than 6 minutes. So in 6 minutes, if your DROSS is 1 ton, you can recover 250 kg aluminum, rather than spreading on the shop floor and then making it dirty, fumes coming out, unhealthy, dusty atmosphere. Everything is stopped. Next slide. So DROSS press design is a very important science and behind compression. So science behind compression, sorry. So mainly alloy, what type of alloy you are making, that determines the quality of the DROSS, whether it is a dry DROSS or wet DROSS. Then there are furnace dimensions which determine the size of the pans. Sometimes you in the drossing cycle, first drossing is where you generate more skimming, so you require big pan. But if your drossing is such that in the next cycle, in the next drossing cycle, your dross generation is less, then your dross pan can be reduced to less size, because the dross pan should be more than 85% filled before going to compression. So these are the design aspects. What are your skimming cycles? Because your bottleneck is 6 minutes. So if you have one press catering to 4 furnace, each furnace having 1 cycle, and in 1 cycle there are 2 cycles of skimming, and so much of dross. Since so much of dross means so many pans, so every pan has to be given a justice within 30 minutes of the skimming. So that's a design factor. Then fume extraction. So whether your DROSS press is near the common fume extraction or you need a fume extraction, a separate unit which can be provided. And then there has to be a storage area for compacted skull. Now you don't get skull immediately. You have to take the pan out, put it for 1 hour cooling, topple it, and then they take the pan back to the furnace. So that has to be at a designated place, which is also strategically should be located so that you can keep on stacking the skulls one on another. So there are many points. Currently, we are working on a big project in India, and if that things materialize, then this DROSS press will have a major role in giving them this a big customer of ours, a big relief out of the in-house DROSS recovery. There are a lot of politics involved in the DROSS management outside the factory, but if we adopt DROSS press, in-house recovery will give you a lot of money from your. It's like unlocking the value. So ALTEK DROSS press are long life, 10 years, nothing will happen. It has a proprietary DROSS pan metal composition. DROSS pans are not deforming anytime, and it is made up of cast steels to run for years. Every 1 metric ton DROSS squeezes up to 250 kg minimum of liquid aluminum. That is what we feel, but depending on the DROSS percentage. So if you 1 metric ton DROSS gives 250 kg aluminum, you can imagine in a day 1 metric ton multiplied by 365. Chalo, take a simple calculation. So in 365 days, 1 metric ton DROSS means you are saving $228,000 of aluminum in-house. No need to take the DROSS outside for processing, selling to the vendors, and landfilling or any other thing. So you can imagine if you multiply this factor by number of operations, recovery cycles, weight of the dross, everything, this is manifold, many folds. Okay, next slide. See, the science behind the compaction is when you start compacting, the press doesn't compact one at a time. It's like a sponge. So when there is a sponge full of water, you compact one, then you compact second time and compact 3 times. So likewise, when you start compacting, the first, like a low hanging fruit, the liquid aluminum will drain. So there is a vacuum. So the unpressed aluminum particles in the dross will try to agglomerate. So in the next compact, it will drain more. In the third compact, it will drain more. That is how you recover more. So that technology is already inbuilt in the dross press head through the control panel. So we sequence that. It is not like the dross head goes up and down. It is releasing the pressure. That's all. In conventional, before pressing, you can see the dross. After pressing, it is a solid skull. Next slide. Yeah, current conventional without dross press, you can see this mess. But after dross pressing, the skulls remain in this well-mannered stacking positions. Now, this skulls has a lot of aluminum inside. On the left-hand side is a dross left to open. It has a dust, hazardous fumes, and lot of aluminum converted into aluminum oxide. And due to thermiting, lot of aluminum into the atmosphere. So it's a big loss. But in terms of compaction, within 30 minutes, in 6 minutes, you are recovering out of 1 ton, 250 kg. Same cycle for 365 days, you are recovering $225,000. So कितना हो गया? 1 करोड़ 20 लाख रुपए आप लोगों ने रिकवर किया. Yeah. So next slide. So after this, the skull goes to a recovery process for balanced aluminum recovery. So this is called as a alu salt slag recovery. So what happens is the skulls are broken into pieces. They are put into the tilt rotary furnace, which you must have seen in the first video. And in the tilt rotary furnace, then you add the salt flux and start the furnace, and then you recover the rest of the aluminum, major aluminum. You decant it and balance salt slag with the remaining aluminum goes for the mechanical crushing. You recover the balance aluminum. So total aluminum recovered there is 70%, and in the press you recover 25%. Mostly we have faced a question why we should if we compress the dross and the skull is big, we need to break the skull for the outside vendor to get it convenient. But people forget 25% you are recovering in-house rather than giving it outside. So there is no, I would say, high level of kind of argument to ignore this in-house recovery up to 25%. That skull, if it requires a mechanical process to break, to give it to the vendor, fine. But why we should do that? We should also implement the alu salt process with 5 cast houses. You can bring all the dross at one place, put it through alu salt process. ALTEK is ready to invest in alu salt plant and machinery and give you the aluminum. The residue of the alu salt process will go back to steel industry. That financial model can be easily worked out. So ALTEK has made up mind that in India, they are ready to invest in the plant for alu salt process. Next slide. There is a process called RAME technology. It is a proprietary technology and it is used in Alcoa. It is a saltless process where I don't know much, but they are using the induction furnace to melt the dross in a certain manner so that you can recover the aluminum, and the balance is the output which goes as a bath cover. So RAME is a process specifically designed for primary smelters, achieving excellent yields higher than tilt rotary furnace with salt flex operations. And it is a salt-free process and has the flexibility to produce all dross types. developed by Lefebvre. The unique feature with this process above all other than is that 100% of the output dross residue from the process residue is inserted into the electrolysis cell, that is the bath cover. There are certain concerns here in the smelter that the bath will get contaminated, but no, the technology is so robust that it will give you the bath cover and the aluminium. So nothing is, it's a zero waste recycling. This is a proven process operational for last 4 years at Alcoa smelter, processing over 17 different dross alloys. And it allows other smelters the opportunity to maximize their dross value. For the first time, conserve aluminium units to reduce their carbon footprint and boast a truly circular economy process for their dross management. So nothing best can be done than 100% recovery of the aluminium. But saying all said and done, first recover what is low hanging. So the low hanging is compaction of the dross. And it is a common sense that one should implement the compaction of the dross. Yeah, next slide. So I stop here. I think I have exceeded my time limit of 1 hour. I am very sorry. But big thank you for patience learning, listening to me, not learning. Big thank you from me as a half marathon runner. This is my email ID. Please don't ask me tough questions. I am very weak in my knowledge.
No, it was an excellent teaching and from excellent teacher. And really it is the modern approach to furnace optimization. I think who are experts like there are few people experts in smelting. They will be able to convey. And if there is any question, one can ask here. Thank you.
Good afternoon. My name is Murthy. Thank you very much for the wonderful presentation. I'm basically from pot room process control. So it is interesting to know that when we send the metal to the cast house, what are the things we are generating there, and how, again, there is a process to further recover and go towards the zero waste and the landfills. Excellent way it has been explained, and the principles are also clear. But one thing I would like to point out, sir, so because you said at the end, there is a RAM technology. I believe it may be the removal of alkaline metals, if I'm right, ma'am. So you'll be removing from that and you will be sending it back to pot room as a bath cover. So if we have chemical analysis of that material, it would be very useful for people to understand for the suitability of the bath cover.
Yeah, this is the project which has been of high interest to NALCO. Maheshwarji is very much kind enough during the IBAAS visit to NALCO. With his blessings, NALCO guys showed more interest, and the RAM technology is under very high level of consideration at NALCO. It is a perfect example of circulating the entire dross, recovering 100% aluminum within the NALCO premises, and taking the bath, which is as a bath cover, the residue as a bath cover, which will not contaminate their pot rooms.
Okay.
My knowledge is very Mickey Mouse.
So thank you, sir. Thank you. But at least if you can somewhere able to give the analysis of that material, that would be very helpful.
Yes. Mr. Murthy,
Yeah.
you can share your email IDs to Arun, and he will send it to me, and then I will try to get you maximum information.
Yeah, only chemical analysis part of that, and now like iron, silicon, and all those things.
So you
Yeah, but it
can
is less than what is required. It will. One thing I know is it will not contaminate the bath, so it will be less than what is required.
Okay. Thank you very much.
Thank you.
Yeah, it was an excellent presentation, Mr. Deshpande, and I welcome. Yeah.
Manish, I have learned from you.
Okay, that's fine. But the technology I was not knowing. I was knowing only steering, this magnetic steering. Then now what you talk about more advanced control systems, that bubble analysis, that is very creative, and it is world breaking. So
Yes.
that technology is very innovative for entire metal industries, rather not aluminium. And one thing I want to speak, that head, that press, that head, head, throughout the head, periphery of the head, there is any leakage of aluminium.
There is a leakage. If your drossing is not professional, then the
Yeah.
drossing operator will pull more dross, more aluminium by
Okay,
putting the
okay.
blade inside. If the
Mhm.
if it comes if theoretically the aluminium in the dross of the alloy,
Yeah.
alloying aluminium is this. If you are putting
Mhm.
more aluminium, when you press, it will spill off. But when it
Okay.
spill off, the speed of the press is slow, so it spills and it covers the border of the skull. So it is aluminium trapped in the skull. But it is
Okay.
always better to recover the aluminium in the bottom pan rather than on the skull.
Okay. 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 Good.
Yeah.
Thank
But
you.
the quality of the skull is so very nice after the compaction that it has maximum aluminium trapped inside.
Mhm.
So far I know about other processes, but by keeping the dross open for cooling and everything is a age old technology. So
Yeah. In Italy, I think in Italy there is a technology by some company. They recover about 75%. I forget the name. I saw that in IBAAS exhibition only. That company, Izzi or something. I forget the company. Okay.
yeah,
Thank you.
yeah,
Many
yeah.
thanks. Yeah.
Mike, thank you, and I will be able to meet you in the coming month when I
Okay.
am in.
Any,
Okay. Sure. Most
any,
welcome.
any comment from Mr. Kurt? You are muted.
Thank you,
You are-
Mr. Kurt. Guten Morgen.
You are muted, please. Unmute.
So, Mr. Kurt, which company do you represent, or Arun?
No, he is muted. Let him unmute, and then he may be able to tell.
There, how's that?
Yeah, we
Good
can hear you.
afternoon, happy Friday. Okay, you can hear me now, right? Okay. No, I'm with Hydrogen on Demand by Algalco. We found a way to depassivate aluminum. So when you add water, the net impact is it generates hydrogen on demand, and my byproduct is aluminum oxide with some of the catalyst left over. So we've done work with Hindalco, Alcoa, Rusal, MIT to be able to recycle it. So it's a hydrogen feedstock that is completely renewable. So we have a system. We put it on, our first application is for mid-sized trucks, and right now we're scaling it to what we call in North America Class 8, 80,000 pound over-the-road trucks, because you put a little bit of hydrogen in that and you increase your mileage about 7% and reduce your NOx emissions by 30%. And they haven't found any other way to get rid of the NOx unless you go to fuel cells or electric batteries, which on an 80,000 pound truck is just not, it's not a practical solution. So we have been engaged with your group for, I think, 2 or 3 years. There was a potential group that would be able to recycle our byproduct, because in India, that's aluminum is a big industry, as you well know, and it's there's a high level of interest. So what we're doing as we scale is we want to be able to create enough volume of byproduct of the aluminum oxide and to be able to use one of your smelters. I mean,
Yes, Kurt, you have my email ID. Arun or Priyanka can show my email ID. The last slide. You can drop me an email. I am very much my initiatives. My role is technology initiatives in India.
Oh,
So
okay.
this is my email ID: ex_k Deshpande @harshco.com. So Harshco particularly deals with the steel slag. So they recover steel out of slag. So they put the plant inside the steel plant. So the plant in plant, and they make the investment. So with Harshco and with Nalco, we will be putting the RAME technology in India if everything goes through, and we will recover. So if we look at your collaboration, then we can think about moving further.
Okay.
Because of the underline, the email ID has that _ex_k Deshpande @harshco.com. You need to be very careful.
No, or you can approach our office, IBAAS office, and to all participants, you can ask any question through mail also. And I think Mr. Kiran Deshpande will be able to answer most of them. So
I will try.
okay, you are an excellent teacher. I hope you will answer all questions. So
I have a
teacher
question.
is-
I have a question.
yes, please.
Yeah, the question is that how is your DROSS processing technology different from the one which Alba has developed and which I think Vedanta is using it?
Sorry, first of all, my question to is who is speaking?
Jagdish here. Sorry.
Jagdish. Okay. Jagdish, honestly, I do not know about the other technology. I don't know. But they are certainly not compacting the DROSS. That is for sure. So that is one. Number two is in Vedanta, a company called Runaya is making the entire DROSS management, something like that.
Yeah, correct. Yeah, that is. I also know a little bit about it only. So that
Yeah.
is.
But Runaya has come to us.
Without flux.
Runaya has come to us to improve their technology. So
oh, is it? Okay.
I don't. so we are dealing with them now.
I see. I'm just trying to understand.
It is not about outstanding technology. It is about applying the science at the first place for low hanging fruit. So we are compacting the DROSS, which is a low hanging fruit. Take 25% aluminium, immediate money. Then you start doing anything out of this residual skull, which has a high content of aluminium. Then that's a separate chapter.
Okay. And secondly, the magnetic.
Mr. Murthy, you can also drop me an email. You had asked me an interesting question.
Sure, sir. I'll do that. I'll drop an email. Yeah, thank you.
The second question is that the magnetic stirrer, what you are proposing, the existing furnaces can be modified, or you need
Yes.
a retrofitting?
No, retrofitting is possible. Existing furnace needs to be modified if it is bottom mounted. If you have a place below the furnace where this EMS can go, then bottom mounting of the EMS is the first preference because it is the best way of putting the EMS energy.
Okay.
But for that, you need to retrofit the bottom. So you need to really look at the bottom structure without compromising on the stability of the bottom, load bearing capacity and all those. You have to modify the structure, put a particular stainless steel plate of our composition. We have a proprietary composition so that the magnetic field can pass through this stainless steel plate, pierce through the bottom ceramic layer, through the bath and stir the bath. So it is possible. Retrofitting on the side is also possible.
Okay. That's all I have. Excellent presentation for you. Thank you.
Okay.
Thank you.
Thank you very much, Mr. Kiran Deshpande. It was an excellent presentation. So thank you all. Let us close now. And if you have any further question, clarification, you can write to us. You can write directly to Mr. Kiran Deshpande. His email ID is already there. So thank you very much.
Thank you. Thank you.
Thank you.
I hope my taking your time was meaningful.
Yes,
Last
yes, it
one.
was.
Yes, it is. Yes, it is.
It was not time. Okay,
Okay,
thank
sir.
you.
Thank you
Okay,
very much.
Mahesh,
Okay,
let us
fine.
meet in Bhubaneswar.
Yeah, sure. Most welcome. You are most welcome. Yeah.
Okay, sir.
Thank you, Mr.
you.
Kurt. Bye bye.
Thank you.
Very good.
You-
Okay, sir.
Bye.
Bye-bye.